we're the 73% of producers having foreign material incidents on a quarterly basis. This came from a market awareness study that we did do internally last year, but it was a large study. We sent this thing out to several thousand people and got several hundred answers back in terms of what people see and how frequently they saw it. But we were seeing 73% of people who manufacture in food are having some type of a foreign material incident on a quarterly basis. Now, doesn't mean it's something that we're involved with, but it's something that you guys have the opportunity to deal with internally as part of that process. So when we think about how it enters into the marketplace, we talked about raw materials, and Brian had alluded to this earlier. Getting buckshot into product. That's something that when I first joined FlexXray 3 years ago, and these guys started telling me that we were doing X-ray for buckshot, I'm like, how in the world is buckshot getting into product? But it is. It's something that we deal with quite frequently. We get a lot of questions. It's like, what are some of the oddest things that you see, and what are the weirdest things that you've seen in the system? And I won't get into a lot of it, but I will tell you that last year we found a full bullet slug in a chunk of pork ham that had gotten in, and somehow we got in, it didn't get disintegrated, and the whole bullet slug was there. And that's not what we were actually looking for. We were actually looking for a rubber gasket, and we found this slug in the ham. So that was kind of interesting. But it's one of those things that you just never know where the foreign materials are going to be coming in. They're coming in from all different areas, and obviously in processing, we talked a little bit about that. But one of the more common things that we deal with, especially in protein, is looking for bone and looking at bone debris and bone down to a certain size, and whether if you've got a boneless product, you're not supposed to have any bone, or what size of bone is okay as part of your risk management program. We talked about risk quite a bit earlier, and how do we deal with that from a risk management standpoint. Obviously and these guys alluded to it on the panel when you're talking about the equipment and components within equipment starting to break down, and where does that come from? And they gave multiple examples, so I won't get into a lot of it, but it comes from all over the place. And some of the things that we hear from the industry as to where some of these things occur, having been in food safety for a lot of years now, some of the things that I hear, it's like, wow, that's one that I never thought about, because it's just, these are the things that you don't think about either until we have an incident where we have an opportunity to work through something. And then obviously, when you've, and I think, Brian, I think it was alluded to this, as you get a whole wrench that's laying in got into a process, and maintenance didn't realize it was going until it was too late, or you get different types of components or different types of tools that get into the manufacturing process. So, it's coming from everywhere. It's a matter of how you're able to determine where it's coming from, what your challenges are, supplier programs like we talked about, co-packer identification programs up front. There's just all types of different things to consider when you're looking at what's going on from a foreign material standpoint.
So first, I'll introduce myself. I'm Kye Luker, Chief Product Officer at FlexXray. Spent a little over a decade in the food industry, causing most of the problems that I help customers solve today with foreign material, mostly in operations and quality in my previous life, and a little bit in engineering as well. And now everything that we're doing is trying to find novel, new technology, even medical type technology, in order to find foreign material that can't be found during an inline inspection event. And so the panel earlier talking about a lot of different facets as it relates to the plant itself, and whether it's line extensions, construction, wear and tear, routine maintenance, all of these things are common sources. You guys are dealing with these issues every single day. A new line extension, equipment replacement, things like that, whether that's a missing or lost part, construction debris, always one of my favorite events during construction, even if it's just going and replacing something like a meter or a device out there, and somebody changes a piece of wiring and clips a piece of wiring, and that the small gauge wiring gets lost and ends up in a food product or something later, because wire is such a difficult thing to find downstream. Maintenance on equipment, we could talk about that for days. I'm glad that sanitation got brought up multiple times earlier today. O-rings, gaskets, those types of things that could commonly get lost during a changeover event or a sanitation event. And then finally, wear and tear. Metal on metal contact, it's the #1 source of foreign material that we're all dealing with on a daily basis. And we're fighting that, every day as it relates to grinders, pumps, extruders, cutters, everything out there, trying to eliminate metal-on-metal contact.
Great. And then obviously, and this came up in the panel discussion as well, when you start looking at what's going on from a foreign material standpoint, there's so many different factors that you got to consider in terms of what it costs, from the incident that you're dealing with, and I think everybody on the panel, alluded to this in one way or the other because you're looking at things differently. But obviously, you've got the cost of the product. That's never a small situation, and so you got to determine, exactly what does that mean? How is the product bracketed? Do you have 50,000 pounds of product? Do you have 500,000 pounds of product? A lot of it just really depends on what your bracketing process is internally for your foreign material programs. And then again, I think I mentioned this earlier when you talk about inventory and what does that mean in terms of meeting your customer orders and getting product out to your customer and or shorting your customer. And then what does that mean in terms of customer relationships, because it can damage those customer relationships that you're working with if you're having to short it, because they're going to find the product somewhere. If it's something they got to have to continue running, especially if it's you've got a customer that's going to make further product, they're going to find the product somewhere. And you got to think about, if you do find this and you've got a situation, what is your opportunity cost to rework the product internally? If you've got inline X-ray machines, you've got to shut down a line to go back in, or unless you're lucky enough to have an offline inline machine, which we don't see that a lot. You got to shut down a line to rerun the product. So now you've got the cost of production that you had there, plus the lost cost of production. So this opportunity to rework internally, when you start doing it, it's just, there's so many factors to think about that a lot of times that we don't think about. The brand reputation, I know the panelists mentioned that. We obviously want to get ahead of that. Nobody wants to get something out there where there's a recall where it impacts your brand. And I know everybody's trying to put preventive maintenance programs in place, or preventive programs in place, so that you're not running into that, so that you're not getting those out into distribution, so you're not having the recalls and you're not having the situations that go along with that. And then obviously the last thing you want to deal with is some type of a regulatory situation and the agency getting involved because you're outside of compliance with what's going on, and then any kind of fines associated. So when you start to think about this, it's like the panel said, it's important to have all the persons within an organization involved. It's not just food safety and quality. You got to have operations, you got to have procurement, you got to have everybody involved. And one of the other things that's becoming more and more common is not necessarily a cost, but what does it mean long term downstream, and I'll speak a little bit to this later on, is what does this do for your sustainability numbers or for your sustainability goals? When you're keeping product out of the landfill, now you're starting to impact what those sustainability numbers are, and we know that there are procurement agreements that are being made based on persons or companies' sustainability numbers and their carbon emissions numbers, and so there's all these things that go into the equation that we need to think about.
So let's take a second and talk a little bit about the tools that are at your disposal from a foreign material inspection standpoint in line. Almost all of us are familiar with metal detection and X-ray. That's the most common two items that are used in a food plant today. Vision and hyperspectral AI was mentioned a few moments ago, and this is really where AI and machine learning comes in. It's training a vision system in order to know exactly what to look for, whether that's training it on quote unquote good product over and over again where a deviation is easier to find. But with vision systems, that's mostly RGB color spectrum. It's used for mostly qualitative analysis currently, but you can use that to leverage the inspection for foreign material. In fact, if you're in the nut industry, it can identify a hull or a shell versus the actual pecan or walnut. And then hyperspectral takes that style of application and adds NIR to that as well. The limitations are it's surface area based, but if you had a table where you were dumping out trim and you're evaluating things before it goes into a grinder, at least on the surface, it could find things like plastics that are traditionally much harder to find with an X-ray or some other detection device. Microwave is my favorite from a foreign material, but it's also the most limited. Essentially, you're training a microwave and a computer what the signal that a microwave emits whenever it evaluates your product, and anything that deviates from that signal is potentially foreign in nature. It's very limited because it needs to have a consistent, homogeneous product stream. So dairy industry is the best place to see that in action. White mass from a yogurt or cream cheese perspective, where we're funneling something that's consistent through a microwave, and anything that's not the product can be triggered. And then finally, CT technology is emerging right now. It's the same as X-ray, but we're applying a gantry in order to create a 3D model of that, and we're overcoming a lot of the limitations that exist within a two-dimensional typical inline X-ray system. So we'll take a little bit deeper dive into X-ray systems themselves here in the next slide. So mostly in a plant setting these days, your maintenance team doesn't know as much about the X-ray as it did the metal detector that it was previously using. You're typically calling in a vendor, getting vendor support as it relates to that. That's a one-off device. And hopefully as we continue to grow and use X-rays, that we improve that at the plant level about what's going on. But so much of what's being dialed up from the vendor and setting that algorithm and training that, it's still needed from an external standpoint. We'll start at the top though. What's happening is we're emitting a photon from the X-ray generator. KV and MA are the two things that you will hear the most. KV is the amount of power that we're providing that photon in order to penetrate the product. And MA is an interaction of how many photons we're firing through the product. And together those are the watts of your X-ray system. That photon, as it passes through the product, is interacting with the packaging material, the product itself, and foreign material inside of there. There's a photodiode, a strip of diodes that are underneath the conveyor. They're anywhere from 0.4 millimeters to 1.5 millimeters wide. And the energy, whenever that photon hits that diode, is then translated into a digital signal. We're then translating that signal into something that a human can interpret to train an algorithm that's grayscale, essentially, across the board as it relates to an X-ray system. Whether you're using a linear diode array, dual energy, a TDI system, all of it's still based around the same X-ray science itself. The limiting factor amongst all of those versions that kind of fall under the umbrella of X-ray though is production speeds are the limiting factor. We can improve detection across the board with inline instrumentation, but nobody wants to cut into profitability from a line setup. So whether it's 100 feet a minute or 400 feet per minute, the limitations in detection are based upon the speed, not based upon the detector itself. Because if we slow down and put more photons through the product, we can improve the imaging results, we can improve the detection. And essentially, that's what we're doing at FlexXray. We'll go with that in the next slide. We'll talk about that a little further. So before we can talk about how we see things, we'll talk about what we can see. I won't turn this into a complete science lesson. So hydrocarbons, HCNO, everything that we're making from a food stuff perspective, kind of falls underneath that umbrella. For metal, everything in the middle trough of the periodic table here, that's the things that are easiest to find. They impact that photon as it passes through those objects, gets deflected or absorbed the most in that area of the periodic table. So for things like plastics, this is where we have the biggest sliding scale. So if it's petroleum-based plastics, HDPE, UHMW, all the things that are found far too commonly in a food plant, those things are still HCNO type based. They're impossible to see with an X-ray. But as soon as we start applying some synthetics to that, things like Teflon, Rulon, Kevlar, we've replaced some of the ends of those chains with fluorine and chlorine. Now we can impact that photon as it passes through and can pick that up via an X-ray. There's some things in the middle of that sliding scale like Delrin and Viton. They can be seen. They're still rather difficult. And then we didn't even get into metal detectable conversation. I'm glad that the panel talked about that earlier, because what people are putting in there and at what quantity and how homogeneous it is, we've seen at FlexXray a lot of variation with the folks that are selling those types of things. And we'd be happy to help analyze those if you are going through a model where you're looking at metal detectable, whether that's barium sulfate injected, it's like the expensive side, down to like metal filings. Barium does release from those over time. So the longer you keep that in place, the less detectable it gets. And then for the use rating on things that have like filings in there, they don't last very long under high heat, stress, pressure, those types of things as well. So pros and cons about doing an inline inspection versus a third party or offline inspection. Inline inspection, my hands are around the product, and coming from the food industry previously, that's really the biggest benefit. Knowing that I know where all of my product is that's on hold and that I can put my hands around and keep that in-house. Keeping my people working, that could be another, a thing that's a pro around doing an inline re-inspection. And then also, depending on the size, I can actually execute that fairly fast if it's a small hold from a re-inspection. Unfortunately, from a cons perspective there, I'm reusing the same instrument that I was using as a signaling device to do the re-inspection. Am I in fact gaining any more insight as to what's in that hold at that point in time? And then do I have a crew that knows how to use or adapt an X-ray to a different speed or a different sensitivity setting? And most often the answer is no. At least in my previous life, it was an X-ray or a metal detector that had gotten pulled off a line as we upgraded, and that one was an offline unit that's now being used for re-inspection purposes. I wasn't really improving the opportunity for re-inspection at that point in time. So what's involved with our X-ray system? Speed, we talked about that a little bit ago. The more photons I can fire through an object, the better image quality that I can get. And I'll skip down to the last imaging on the detectors. An inline detector is 12 to 14 bits. The medical grade that we're using, we're using the same imaging device that's in a heart cath lab for an angiogram, a 16-bit flat panel detector. We can achieve over 60,000 levels of grayscale. We can also manipulate our kV and MA, whereas an inline instrument, it's a single kV and MA that's used based on the aperture that you purchase, the types of products that you set up for your recipe schema for that device. It's locked in place. You don't change kV and MA whenever you change different recipes in there. You're changing sensitivity levels about the trigger points because some of your products influence X-ray detection more than others. So we'll take it in the simplest terms, 95.5 ground beef is very difficult to see through versus 80-20 because the higher fat's easier to pass a photon through.
So I've actually got a question. I've got a question while you're in the middle of that, and I thought about it earlier. So with what you just said, in the term that you're setting up the recipe a certain way, and let's say you get the recipe set up for, you reference ground beef, you got it set up for metal at a certain size within ground beef. If, unfortunately, maybe there's, rubber gasket in that ground beef, but you've got your inline machine set up for the metal in ground beef, are you going to see the rubber gasket, or is your recipe set up so tight that you might miss things that you aren't specifically set up for?
There's a significant size trade-off as it relates to things that are non-metallic with an X-ray. So traditionally speaking, although we can find things like glass, ceramic, stone, bone, Teflon gasket, those types of things, if we're setting that X-ray up to be a really good metal detector, let's say that it's 2 millimeter stainless steel that we've challenged our vendor to set us up with in this recipe, we're probably limiting, I'll take ceramic, zirconium ceramic on a pump seal, which is a little bit easier to find than aluminum ceramic. We might find that at 3 millimeters, but we're probably not finding, soda lime glass under 5 millimeters. It's just the trade-off in the speed and detection that's needed in order to maintain that recipe. The recipe's not working on finding different objects. The recipe's really working on finding a certain level of grayscale, and we're telling it when to trigger at that point in time. The detector doesn't know the difference between soda lime glass and stainless steel.
You got anything else on that one?
I could talk all day, but I think we should move along.
You've got plenty of time. No, I think one of the key points, though, that Kye did mention is the speed. When you're looking at, especially when you're running the inline machines, they're running at the speed of the line for the most part, unless you adjust them down, which is 100 or 120 feet a minute. When you're doing something outside, with a third party, like what we're doing, ours on average are running about 4 feet a minute. So you get back to this point that Kye was making of you're slowing it down so you're able to pick up and able to find things a little bit differently, due to the fact that you're running the machines that much slower. There's certainly some value there.
Yeah, I did want to add to that point. Thank you. An X-ray, or a metal detector, we should think of as a check engine light. It's a signaling device. It's not a measuring device in our food plant. A check weigher is a measuring device. We're getting data off of every single point that it measures, but we're not receiving data on every single thing that goes across the X-ray. In a few years, we will have those types of detectors that we actually can see the noise that's going on in the system before we ever trigger something that's above our threshold, but we don't receive that right now. And so it's a big risk to use an inline instrument as a measuring device when it's not intended to be. It's intended to be a signaling device.
Kizzy?
So I think we're primarily meat and poultry folks in this room, unless we let the vegetable crew in at some point, which is fine if you're with vegetables. Can you talk a little bit about what's kind of unique about meat and poultry products? I know you mentioned like 95 ground beef is a little bit different when you're looking at 80 ground beef, but what about when you're looking at bone-in products or some of our even more complicated products?
Yeah, absolutely. In the protein world, everything that we're evaluating has the potential to contain bone. And at what point in time, from a bone size, calcification, all of that, does that need to be a trigger for its own source of foreign material? And you're right, as it relates to bone-in product, if we are inspecting bone-in product, the X-ray is only a metal detector at that point in time, because the calcium that's in the bone is so similar to glass, ceramic, gasket, even aluminum from a metal standpoint is still going to look and act like bone under an X-ray. We're only going to find ferrous, stainless, brass, copper, those types of metals.
So on the inline side, you have a detection level of 1.5 to 3, and I've seen many applications where people are auditing at 0.8 or 1. So those numbers seem quite large compared to kind of current level of detections for inline X-ray. Am I kind of off base there, or I'm just kind of wondering where those numbers came from? And then even on the discussion about the single KV and MA, all kind of current inline X-ray have KV and MA set up per product. So the detection level on the inline side, I think, is significantly better than kind of what you have up there, and just wanted to share that kind of thought and see where.
No, you're 100% right. As the detection level of the equipment itself outpaces those numbers. You'll see that on every single manufacturer's website, their sales slicks, the materials, everything else like that. These come from real world examples. What's in your food safety plan? What detection, what spheres are you actually using to challenge those machines at your production speeds? And especially within protein, where bone is considered, an indigenous piece that impacts the detection capabilities. Not often is everyone getting down to 0.8 with an inline X-ray. The machine itself is capable of that, but not often am I seeing people using test spheres at 0.8.
Yeah, personally, I've seen quite a few on the meat side, because that's generally a rework or a release level, so they're trying to get to that. And there's a big push by suppliers to some of these end users to go smaller and smaller and smaller, so they don't have on-hold or events or kind of chargebacks. So I just want to share my thought. I just saw it up there and thought I'd add a comment. Thank you.
No, and it's certainly something that we see as well. It's a common thing in the industry. We got to get smaller, smaller, and smaller, and be able to find things as small as we can. And really, I think what it boils down to is the repeatability at which you can find stuff that's very, very small. Because you can find stuff very, very small. We can find stuff really small on a periodic basis, but we can't find it at a repeatable level that we feel like sometimes is repeatable enough that we can tell the customer in good confidence that we feel like we can run this project. One of the things that we used to would do, and I won't get into all the specifics of it, but it was like very specific. If we can't find something that's repeatable and it was like 99% repeatability, we can't run the project for you. And these guys mentioned it a bit earlier. Now our customers are having conversations of, okay, we may not be able to find it at 99% repeatability at that size. We can find it at 85%, and even at 85%, it's not a choking hazard, it's not a health hazard, it's not something that's frankly, you're probably even going to know that's in the product at some point in time. So as a manufacturer, now you've got to make a risk-based decision. Is there a risk with putting this product into commerce, knowing that it's not 99% repeatable, even on a third party. So there's all type of different options to look at, but that repeatability thing I think is a big one. All right, so when you talk about looking at in-house versus third-party, we've talked about a lot of the information in this slide already through the panelists. They've gotten into a lot of the information, but one of the things, and I think it was Tabitha that said this, is really the inline manufacturers. One of the things that or not inline manufacturers, but the folks that are working in the plant, it's really not their core competency. To set up either X-ray machines or metal detectors and do all the calibrations. Their job is to run food products. So that's something that, that as you work through the food safety and quality programs, you're going to have to make sure that, that if things are being changed or recipes are being changed, there's that opportunity to train your people internally to do that the right way. Obviously, a food plant is there to produce food as fast as it can produce it and get it out into the marketplace, because that's key to what's going on in the marketplace. And do you slow down? Do you shut down lines? Do you bring people on the weekends? How do you manage that process of reworking internally? Obviously you got the cost of labor and the downtime and all the stuff associated with that. And what if the inline technology is not finding the form material that you're looking for? Again, we advocate the use of inline technology. We think it's something that the industry needs. We feel like it's a great indicator for what's going on out there in the marketplace. But just like we have limitations around certain plastics and those kind of things, all systems have limitations. And so you got to go through your risk analysis to determine what the limitations are and when it makes sense to look at outsourcing. One of the things that we feel like as a result of some of the things that Kye's talked about is when you're looking at third party, more precise technology, slower inspection speeds, which gives you some opportunities to find some things that you might not find if you're trying to rework it internally. Obviously, you don't have to resource, or you don't have to come up with your own labor and your own costs associated with the rework, because we all know the challenges that we have in the labor pool today. So it's not easy to find the personnel to do that type of work. Trained inspectors, obviously that's our core competency. Food manufacturers' core competency is manufacturing food, and so how do you do that? And then when you think about it, you look at it from a quicker turnaround standpoint, and that could be variable. It could be that if you've got 10,000 pounds on hold, then it makes sense to to take a few hours at the end of the day and rerun 10,000 pounds in line. If you got 1 million pounds on hold, which is, we see that, it's not something that's uncommon in our world, it takes a lot of time and a lot of personnel to rerun it. So typically we can turn that kind of a project around much quicker than you might be able to do internally. Just a few things to think about. And then when you talk about is it the best option, I'm not going to belabor this because a lot of this stuff has already been talked about, and I certainly don't want this to become all about FlexXray as a commercial and those kind of things. But these are the things that the panelists brought up, and some of the things that can be constraints and can be some of the challenges that we faced. But the one thing I think is key is when you look at and it's over there technology designed for inspection, it's these third-party technologies. That's what they're for. They're designed to help you handle large events, large incident events, and to be able to find things so that you can keep your product in commerce. And that's really what the processes and the systems are set up for. So something to think about when you're working with a third party. It's not as easy as just saying, hey, we got a box of chicken nuggets we think we got metal in, we're going to send it in, or we got a truckload, we're going to send a truckload in, we need for you guys to start taking a look at it. You really got to take a look at, the first thing you got to do is we have to do an evaluation of the product. If you come to us and say, hey, we need to see if you can find form material X in our product, first thing we're going to do is ask you to send a couple of cases in. And if you've got the form material, we'd like to get examples of your specific form material. If not, we use seeds that we have, and we're gonna run it through the system, and we're gonna tell you we can find it down to this size at this % repeatability. And that's what it's all about. And if we can't find it, we're going to tell you we can't find it. We can't find it at a small enough size at the repeatability you need to be able to feel good about telling you, to run the project. We're going to be able to help you out. But then you work through, and one of the things that wasn't mentioned, I think, earlier today was logistics, and how do you work through logistics and getting truckloads sent, and you've got to get your logistics team engaged early on in the process so that they're working directly with your third-party logistics team, and you're determining what time of day that the trucks can get to a facility, so that the trucks aren't sitting there, overnight, unless it's a drop load kind of thing, so that you can get the truck turned around and get it back on the road really quickly. Typically you'll see, I know in our world, if we're running a truckload of product and we can do it in the case without having to take product out of the case, we can typically turn an entire truck around in somewhere between 4 and 6 hours. So it's most of the time the driver's sitting there with us. The driver's staying there waiting with the truck. We get it turned around, it's reloaded, and it goes back out into commerce. So those are the kind of things that you have to think about when you're going through the evaluation of a project, versus whether you do it internally or but especially when you're looking at what you're going to be doing outside. And then obviously you're going to be looking at, we talked about earlier, those risk levels, and what are you really looking at? What is the percent repeatability, and is it going to meet within your food safety goals and what you need to do? This is just an example, of a third-party inspection report. If you guys haven't used a third-party service in the past, for doing this kind of work, coming out of the lab business, when I first got to FlexXray, I'm like, they have literally copied my COA that I used to send out for microbiological or chemical analysis, because it looks very, very similar. You're getting a whole lot of the same type of information. You're identifying the product, identifying obviously the SKUs and everything that goes along with it. But one of the key things, or 2 or 3 of the key things, is really there's a complete manifest of the products received and are rejected and returned, because that's key. Because the goal is, when you're sending these projects in, is we want to keep as much product as possible in commerce. And so we've got to have that complete manifest so that we understand what we've got, we understand what we pull out, and we understand what's back on the truck that's now going back into commerce. And that's key for you guys, because that's where your ROI comes on these kind of projects, is keeping as much product as you possibly can into commerce. You got temperature monitoring logs. I will tell you that our warehouses where we actually run the inspection rooms are not refrigerated rooms, and that's something that we get asked often. And customers are like, well, how do you take care of the situation? We have a protocol for checking the temperature when the product comes off the truck. If it's a refrigerated truck, we have a protocol for checking the temperature when it goes back on the truck, and the temperature can only vary a certain amount of time. Depending on the kind of product, you may split that product across multiple inspection lines in our facility so that we can turn it around quicker, so that we can make sure the temperature stays where it needs to be. For example, ice cream. Obviously you got to turn ice cream around pretty quickly, because temperature, any kind of a temperature variation there can be a real problem. And then we've got traceability of the product, from the time it comes off the truck to the time it goes back on the truck. It's key to have that traceability for you guys, so that you know what came in and what goes back out. All right.
And the last couple of slides are just some examples, just in protein and poultry. Different products are coming off different production lines, fresh, frozen, processed, ground, sliced, dried, pre-cooked, canned, jarred, you name it. And every single one of those production lines has its own unique inherent risks of foreign material types. And the thing is, we can essentially find all of those things. Now, an X-ray cannot find UHMW and HDPE type plastics. It's not going to be found, because it's petroleum-based plastic. So high density plastics, even though HDPE stands high density polyethylene, there's nothing that's dense about a petroleum-based plastic. Teflon, Rulon, Kevlar, those types of things, Buna, depending upon the type, and again, nitrile, depending upon the type. Nitrile is one of those difficult things from a plastic standpoint. It's a good replacement for UHMW in our food plants, because it holds up to chemicals very well. It's pliable, it doesn't break. It can be put into many different color codes and types, but depending upon how that Delrin was made, it can impact the X-ray detectability of that Delrin. So there's 2 companies that make utensils in a food plant that are color coded for different things, and there's many other competitors to them, and they use a type of Delrin and an additive that's easy to see under X-ray. When I say easy to see with the medical grade imaging device. From an inline standpoint, it's difficult to get down to small sizes, maybe 4 or 5 millimeters with an inline instrument, but no issue getting down to 1.5 to 2 millimeters with a medical imaging device, because that type of plastic fluoresces very well. And then the very same thing from a poultry perspective.
You know, speak to, can I speak to this, because I found this interesting. Speak to the challenges with looking for bone in poultry due to the rate at what we're now growing poultry and how quickly it's growing and how little calcium getting into the bone.
From a maturity standpoint, obviously the calcification in a poultry bone is at its lowest levels, you know, when we're processing now. So poultry bone is starting to become almost as difficult as a fish bone to find as it relates to an X-ray unit, you know, especially compared to beef or pork.
All right, so those are all the slides that we have around processes and practices, and you know, any questions, we're running a bit ahead of time here, so happy to take any questions anybody may have. You got one back in the back?
When y'all are detecting bone for X-ray, what standard would you use just for a verification of it? A test standard?
There isn't a defined standard yet as it relates to the industry. We use aluminum ceramic, aluminum oxide. We use aluminum oxide from a test sphere standpoint because that's the only standardized spherical test seed that mimics the same density as bone, but there is no standardized result right now. If you are going to use live bone, just be sure to save that in whatever it came out of. Don't let it dry out at all. If you can put it into some gelatin, if you're going to use live bone as a test seed in your plant, because as soon as it starts to dry out, it becomes undetectable under X-ray over time.
I've seen people use glass before. Do you not recommend that?
I don't recommend glass because glass has a specific chemical makeup that's a little bit easier to see. The silica in glass will fluoresce under X-ray. The calcium and sodium in glass, that's closer to bone, but aluminum oxide, Al2O3 spherical seeds look like, essentially it's aluminum with the crystalline structure, and aluminum does not fluoresce very well under X-ray, which is closer to bone.
Any other questions?
Well, I'll mention, Kye, you talked about how the people who are making food, that's their thing. That's what they know how to do. They know how to make food. They don't necessarily know how these machines work. I think it's great you guys kind of dove in and talked about how X-rays really work. And this is a shameless plug for the Foreign Material Manual, but if you have not checked that out, the Meat Institute years ago pulled together a bunch of very smart people from member companies to put together it's a resource document. Do not open up from page 1 and read down to page, I don't even know how many there are in there. It's a ton. But it's a great resource document. And one of the things I love about it the most is we got equipment suppliers to help us really dive in and explain how the different detection methodologies work. So there's a section on X-ray machines. There's a section on metal detectors, on imaging, to kind of help you understand what those can do, what they can't do. And use that resource to help educate your folks too. I found that, helping people understand the difference between a metal detector and an X-ray and how they work really kind of helped people understand what they were working with in the plant and what it can or cannot do. Because I don't know how many times I had maintenance people think they could just take this metal detector over here and just move it over here and it'll be fine. We can just use it over here now. And that's not how it works.
No, and it, to help with the plug, it is a great manual. I've spent a little bit of time going through it, and it's a great resource when you're looking at things from a foreign material standpoint.
Thank you both very much.
So back at 3:15. Thanks.